here at the very top is just another summary of some things written out that we have already talked about. So we have what the vertex form looks like. We know what part represents the vertex. We know how we tell if the parabola is going to open up or open down. So that is just a little section for you to go back and reference. Let's go take a look at a few more graphs. So we are going to be filling in some pieces very similar to what we just practiced, but we're going to go a little bit further. So you'll notice that there's 4 additional things that we are going to be asked for every graph that we make. So let's go ahead and start by identifying the vertex. So opposite value of the number in the equation for the x, so that positive 3, that plus 3 turns into a minus 3. It's the same sign for the y value at the end. And really, as soon as we know the vertex, and in this case we're noticing that a is positive 1, so it's going to open up, just as we saw in that little activity, that is enough information for us to go ahead and make our graph. So let's do our vertex at -3, -2. It's opening up, and a is 1, so there's no vertical stretch here. So we can just go over 1 space, up 1 space on both sides. And then from our vertex, we'll go over 2 spaces, up 4. All right, we're also going to draw in that axis of symmetry line. And by the way, sometimes you'll see that abbreviated as AOS. That's what that represents, axis of symmetry. We're always going to write it as an equation here with an x equals in front. That's what makes it a vertical line. And it is always the same as the x value of the vertex. Because the axis of symmetry is always passing through the vertex. Now the next question here, this has to do with whether it is opening up or if it's opening down. So if our parabola is opening up, the vertex point is considered a minimum because it's the lowest point on the graph. If our parabola is opening down, the vertex point is considered a maximum because it's the highest point on the graph. So here we're identifying which one we have. Ours is opening up, and so we have a minimum. We don't have a maximum. This is going to go on forever, onward and upwards. It's never going to reach a highest point, but we do have a lowest point. When the question asks you the minimum, this is just asking us the y value of the lowest point. That's all that is, and so the y value of the lowest point we have there is -2. Now, you don't have to put a y equals in front of it. If you did, that would indicate a horizontal line. We're not talking about a line, we're just talking about a value. So that's all we need to say there for minimum. Our domain for every parabola is always going to be all real numbers because any x value could be plugged into the equation for a quadratic function. The range is what changes because for parabolas, it's not all the y values that are used. We can take a look here at our graph to see that we only have y values above -2. It could be -2 or it could be anything greater than that. We just don't have any y values that are lower than that. So the range is always about the y values, the possible outputs. So here we're going to say that we only have y values that are greater than or equal to -2. All right, we're going to take a look at another one here that's in a really similar format. And I want you to notice that on this one, now we have a negative in front. What is that negative sign going to do? It's going to flip it down. It's going to open down. You can even make a little sketch off to the side as a reminder that it's going to open down. But otherwise, the steps for getting the vertex are still the same. What's going to be the x value of our vertex? Yes. Beautiful. So we're looking at that +1, but we're going to change it to the opposite sign. What's going to be the y value of the vertex? -5. All right. Let's go ahead to our graph. So we're going to go to -1, -5. This one's going to go off our grid a little. That's okay, because it's opening down. We don't have a lot of room to put points, but we do know that it's going to go over one space and down one space. So keeping that same like overall shape. If we had more spaces on the grid from the vertex, we could go over 2 spaces, down 4, and same thing on this side, over 2, down 4. So I'm just going to kind of estimate where that would be. All right, let's draw in our axis of symmetry. We know that the axis of symmetry is always going to have an x equals in front. What would the value be here for the axis of symmetry? X equals what? -1. Beautiful. Does this one have a maximum point or a minimum? Yeah, now it's a maximum. Because it was opening downward, we have a highest point. We do not have a lowest point. It's going to go down forever. The y value of the highest point is -5. Right here, notice how that's actually the y value of the vertex. So that's what's kind of cool about these two questions, is this is the x value of the vertex, and that's the y value of the vertex. If you get the vertex, you can already answer the next two questions, no problem. All right, what is the domain for this parabola? All the x's that could be used. All real numbers. Yes, it's always going to stand out and get wider and wider. It's going to cover all of the possible x values that we have. It's the range that we always have to worry about. This is going to be different depending on the scenario. Now, here's what's really different on this one for the range. Because it is opening down, we don't have any y values that are up here. In fact, the highest y value that we have, that's actually the maximum point right there of -5. We only have y values that are lower than that. And so we can represent that with symbols a little bit differently than what we did before. We're just going to say that it's only the y values that are less than or equal to -5. We actually didn't have any positive y values, and we didn't have anything that was above -5. All right, so without graphing, I would like you to try to answer number 3. So you have a new equation here, and I want to see if you can go ahead and fill in all 6 of those pieces. Come back together here and look at number 3. So because the 2 in front is positive, it's going to open up. Our vertex is positive 17.5, -21. Axis of symmetry, so it's always x equals the x value of the vertex. Now, this one has a minimum. I forgot to circle that. The vertex represents a minimum value. There is no maximum. And so this is just the y value of the lowest point. It's actually just the y value of the vertex. The domain is all real numbers. Any x values can be plugged in here, but not every y value is going to be produced as an output. Now, for the range, I had to think about a little picture out to the side. So even though it says we're not graphing it formally, I made a little sketch of the graph so that I can think about what type of y values it would have. So knowing that it opens up, knowing that this is our lowest point is the vertex. So the lowest y value that we can have is -21, so it's going to be all of the y values greater than or equal to -21. Notice that these 3 things right here, y value of the vertex, that's connected to this answer, and it's also connected to that answer. It's not a coincidence that it's the same number that's represented in those 3 places. Yes?
So, why didn't the domain not be?
It'll never not be all real numbers for a parabola. So that's kind of the nice thing. Now, there's other types of functions that we will look at throughout the year where the domain might be something different. In fact, let me show you a quick one right now. We saw this back in Chapter 2. We had a little preview. This is when the domain is not all real numbers. Here's an example. So the equation for y equals square root x, The only x values that we're allowed to put in there are positive x values because we cannot take the square root of a negative number. And so not every x value is possible here. So this would be an example of a graph where the domain, whoops, we're going to use an x for domain. The domain is not all real numbers because it's only x values greater than or equal to 0. But what's super nice about everything we're doing right here in chapter 4 is that the domain answer is always this. It's always the same. Okay, so with the time we have left, I want to make sure we have a chance to look at number 5. This was actually our second learning target over there, is to be able to write an equation, not from a graph, but given a vertex, and then given a point that it's passing through. So I want to walk you through how we can do this. We're going to write our equation in vertex form. So I'm going to start by writing the general a times x minus h squared plus k. Eventually, this is going to be a formula that we have to know. So for example, for the test, we need to have this memorized. It's kind of like when you learned y equals mx plus b. I know there's a few more pieces to this, but we have to know all the pieces. So the thing about this is that they told us the vertex, and so they told us that the vertex was -1, -3. And so we can actually fill these pieces in here, so that's actually going to be a +1, right? On the parentheses part, we're going to do a -3 at the end. And so you might think, well, aren't we done? Like, why do we need to know the point that it passes through? Well, the reason why is because of A. It could be vertically stretched out and be like really skinny little parabola like this, or it could be vertically compressed and it could be really wide, or maybe A is negative and maybe it's flipped over. We don't actually know yet. That's why we're going to look at the fact that it passes through the point 1, 5. So let's pause here for a moment, and the numbers that we just plugged in for the vertex, let's make a note there that that is for h and k. Well, what we're going to do now to solve for a is we're going to take the point that it passes through, and we're going to plug those numbers in for x and y. So in the place of x, I'm going to plug in +1. That's the x value of the point that it passes through. In place of the y, I'm going to plug in +5. Now we are going to think back to PEMDAS. We started with PEMDAS and we're ending with PEMDAS to carefully simplify these pieces down, but we're solving this equation for A. So with PEMDAS, this is what it looks like when you have an operation inside parentheses. So we're going to go ahead and do the 1 + 1. That turns into 2. Next step with PEMDAS is we need to evaluate our exponents. So here we're going to go ahead and do 2 squared, and that's 4. Now we have a nice looking linear equation back to what we did on the first day of chapter 1, where we're just going to get A by itself. So let's go ahead and add 3 to both sides. And we get 4A equals 8. Then we divide both sides by 4, and we get A is 2. Okay, so now we're going to put the pieces back together to write our answer as an equation. So we're going to plug in 2 for A. We're going to also plug in the same values that we got up here for the vertex. So what I wrote in red earlier, so we've got x + 1 squared, and we've got a -3 at the end. Notice how in the final answer, we're not plugging numbers in for x and y. We're using x for x and y for y. Like we want x and y in our final answer. We just plugged a piece in for that just for a moment, what we did in green, to help us work backwards and solve for A. All right, So there's one last thing I want to show you. So I know there's two problems here on the page that we skipped over. I'm confident, though, that those are ones that you can do with all that we talked about. Plus, you're going to get a lot more practice here with the assignment for tonight. I actually have a short video clip that I want to show you for how parabolas are represented in the world around us. Parabolas are actually everywhere. And so this is about 2.5-minute video. And then I'm going to go ahead and pass out our homework for tonight, and we're going to talk a little bit about that.